Hello, and welcome back to Introduction to Physics. I thought that I would do a video on how to do next week's lab, but let's first talk about this week's lab, which was on Newton's second law. So you should have completed that lab. It required you to do a PhET simulation and then to fill out information in that lab. So you're going to want to finish that and then email that to me. Next week's lab is going to be Unit 1, and it is going to be lab number 5, and it's entitled Work and Potential Energy. Now I have updated that lab and put the updated version into Canvas. So you need to get out that document now and open it up and have it in front of you as I go through the lab with you. Okay, so you got it? Okay. So if you would, you'll still need to do the pre-lab questions on it. And I'm going to scroll on down until I get to the materials that are used for it. So you are going to need a ramp, and all you really need to have is like a board game board, so like Monopoly or something like that that you can tilt, and then you're going to need a ball to roll down the ramp, and if you don't have a ball, you could use a toy car. If you don't have a toy car, then you could even do it with a Jello box or something like that. So basically anything that will slide down the ramp and then will slide a certain distance once it gets off the ramp, you could use that. You're also going to need a ruler and a tape measure, and it calls for a mass balance to measure the mass of the ball, but that's not critical. So if you don't have a device that you could use to measure the mass of your ball, then that's okay. So you really don't need that for this lab. Alright, so let's go down to the concept introduction. And now we've already covered this in lecture, but it says that the potential energy of an object is given by the formula that potential energy equals mgh, where m is the mass of the object, g is gravity, which is 9.8 meters per second squared, and then h is the height that you're releasing it from. Then another formula that's going to be useful in this lab is work, and work is given by the letter W, and it's the force that's acting on an object multiplied by the distance that that object moves. And then one more formula that we're going to use is going to be friction. So the force of friction is going to be equal to mu multiplied by m times g. So mu is how rough the surface is that the object is sliding on, m is its mass, and then g is gravity again. So go down to the procedure, and first you're going to make a ramp, and it doesn't make any difference how high you make the ramp. Maybe if you're using like a Monopoly board, you might want to raise your ramp to about 8 inches. So that would be a good height to use it. Now the problem with having it too steep is that when the ball rolls down the ramp, it's going to bounce when it hits the bottom of the ramp. You don't want that to happen. So if you keep, and of course if the ramp is too shallow, then the ball's not going to roll very far. So just kind of play around with it to see what the best height is to put your ramp at. So then you're going to take the ball and you're going to place it at a certain height up the ramp. So you're going to measure that with the ruler. Then you're going to release the ball. So in this case it's the green ball that you're going to release, and then when it gets to the bottom of the ramp, it's going to roll a certain distance, and so the ball that was at height h1 would roll a distance r1. Then you're going to take that same ball and you're going to put it at a different height on the ramp, and you're going to release it, and now it will roll a different distance, and we're going to call that R2. So R is the distance it rolls horizontally, and then H is going to be the height that you release it from. Do not measure the distance from the ball down the ramp to the base of the ramp. So that's not the distance that you need to be measuring. You need to measure the height that you're releasing it from. You're going to do that for each release height. You're going to do it 3 times in total, and then you'll take the average of those 3. And then you're going to do it 5 different times. So you're going to have 5 different release heights, and then for each release height you're going to release it 3 times and then take the average of those. So it takes a little bit of time to do this lab. Now you can record then the release height for trial 1, trial 2, trial 3, then take the average of those 3, put that into that column. You're going to have the height that you released it from, and then if you had some kind of a scale and you could measure the mass of your ball, then you could even calculate the potential energy, MGH. But if you don't have the capability of measuring the mass of your ball, well, let's do it this way. Estimate what the mass of your ball is. So it doesn't have to be exact, but you can estimate it. You know that a paper clip is 1 gram. So you could try to think how many paper clips would be equivalent to the mass of your ball. So if you have to just invent a number for the mass of your ball, now if it's in grams, you need to divide by 1,000 in order to turn it into kilograms, because kilograms is the official metric unit for mass. So take your mass of your ball in grams, divide it by 1,000, and then that's going to be the mass that you plug into the formula in order to calculate your potential energies. So now you can complete that very last column, the potential energy column. Okay, then underneath that, that's a picture of my lovely students from last year or last semester doing that lab. So let's look at the analysis part there. It says, what type of energy did the ball start with before you released it? So when you put it at the top of the ramp, and what kind of energy did it have when it was still in your hand at the top of the ramp? And then write down what is that equation that allows you to calculate that particular type of energy. Number 2 says, what kind of energy did it turn into when it reached the bottom of the ramp? So when the ball rolls down the ramp, when it gets to the bottom of the ramp, then what kind of energy does it have now? And then number 3 is, what force dissipated that energy? So in other words, the ball comes to a stop because it essentially is running out of energy. So where is that energy going? What is it turning into? And what force is responsible for causing that to occur? Number 4, let's say you don't bother to do number 4. Okay, and then also don't bother to do question number 5. So we'll leave those blank. But now you still can do question number 6. So it says to graph the height, and the height will be the vertical axis on your graph, versus the distance r, that will be the horizontal axes. So you should remember how to graph using Microsoft Excel. and you should remember how to label the title, and then label the horizontal and the vertical parts of it. So I hope you remember how to do that. And then put that graph where it says put graph here. Then you're going to calculate the slope of the graph. So do you remember that you're going to do a right click on one of the data points, and then click on where it says add trend line. And now this one's going to turn out to be linear, so it's already set up to do linear. And then go underneath it to where it says display equation on chart. Okay, then that will be and then the slope is going to be the m. So y equals mx plus b, so m will be your slope. You are not going to do the application part, so do not bother to do the application. But you can still do the post-lab questions, or if there's any part of the post-lab that talks about something that you did not do, then you can leave that part blank. Okay, so that's your lab for next week. Have your children or significant others help you to do this one. I think you'll find it's pretty fun. So if you've got any questions, let me know. Bye.